Hi, my name is Keigo Ushiyama from the University of Electrical Communications. I will present modulation of handheld objects property through proprioceptive stimulation during active arm movement. This talk will be led by Amazon Polly.
We have previously developed an experience called ViBaR, which is a VR platform that uses illusions to present movement perceptually instead of physical motion. In this experience, users grasp a bar, and vibrations are applied to the arm to induce the illusion of the arm and bar movement. Through ViBaR, we found that the illusion of the object grasped with hands can be evoked by inducing the illusion of the body movement, that is, by modulating the proprioception. What is proprioception? People have a sense of proprioception. Proprioceptions are usually unconscious sensations and are used to perceive the position and movement of the body and the force or effort. The main contributors to these senses are muscle spindles, Golgi tendon organs, and skin receptors. Besides, it is known that proprioception also contributes to the perception of handheld objects' properties such as weight and length. Though users grasped a bar with both hands in ViBaR, people can perceive an object's weight and length with one hand. We asked that could it be modulated that the perception of the property of the object grasped with one hand, by modulating the afferents from muscle spindles and skin receptors? In the HCI paradigm, many VR interfaces have been developed to present the weight, length, and stiffness of the VR objects. If the properties of the grasping object can be changed perceptually, we can develop a VR interface that can change the weight and length as well. In this study, we adopted the kinesthetic illusion as a method to modulate proprioception. The kinesthetic illusion is an illusion of one's own body typically induced by vibrating tendons. The illusion can also be elicited by stretching the skin near the joint, and combined with these stimuli can enhance the illusion. Also, the kinesthetic illusion can change body representation, such as the elongating of the nose. If we think of this illusion as a change of proprioception, these stimuli are methods to modulate proprioception. Therefore, we proposed a method to modulate the proprioception with stimulation to induce the kinesthetic illusion during movement. We first investigated exploratively what perception changes would occur when stimulation was applied at several phases during active movement. Since signals from the skin and muscle spindles are varied during exercise, we thought that the stimulation timing could be an important parameter. Participants were asked to perform repeated forearm flexion and extension at half a hertz, while vibration and skin stretch were applied to the forearm simultaneously. The vibration waveform was a 70 Hz sinusoidal wave, with amplitude modulation of half a hertz, and the skin stretch was presented in a sinusoidal manner, at half a hertz as same as the movement. The vibration phase was shifted, from 30 degrees to 180 degrees based on the phase at which the vibration amplitude reached the maximum at the lower limit of the movement. The phase of the skin stretch was always set at -60 degrees relative to the vibration. To simplify the expression, we will use the vibration phase as the representative phase of the stimulus. The experiments were also conducted under 3 stimulus conditions: only vibration, only skin stretch, and combined stimulus. We asked 13 people to participate in the experiment. We asked them to evaluate the perception differences through a questionnaire on a 7-level Likert scale, between the object's perception with stimulation and without stimulation during the movement. The questionnaire included items about the object's property, such as the weight, length, and center of gravity. We will show only the result of the weight perception. The graphs are grouped by stimulus condition. The value of 4 on the vertical axis indicates that no change occurred. The smaller the value, the lighter the bar, and the larger the value, the heavier the bar. The results are also represented in a box plot for each phase condition. First of all, the condition where no box is shown is when most participants answered that there was no change. Thus, we can see that the degree to which perceptual changes occurred differed among participants. When Wilcoxon-Sign rank test was performed on each sample, it was found that the object was perceived as significantly heavier in the conditions, where the phase of the combination stimulus was shifted 90 and 120 degrees. This may indicate that the weight perception could be effectively modulated, by stimulating proprioception along with the velocity profile. In short, there were large individual differences in the results. However, it was possible to modulate the handheld object's property by stimulating proprioception. We want to improve the experimental conditions to decrease the individual differences, and conduct further investigations so that the perception change could be induced more clearly. Thanks for your attention.